Hi. In my previous video, I already explained about the initial solution by using northwest corner rule, least cost method, and Vogel approximation method to solve the transportation network problem. However, the solution that we found using the three methods actually can be optimized by using modified distribution or MODI, which is I will explain in the next slides. There are two stages to solve the transportation network problem. First, we need to find an initial solution or the basic feasible solution using northwest corner rule or least cost method or Vogel's approximation method. Second one is we can optimize the initial basic feasible solution that we obtained in the first stage. And here I will optimized by using modified distribution method or MODI. To demonstrate how the MODI works, we can consider the below transportation problem. By using the northwest corner rule, this is the final solution. The smaller boxes here refer to the allocation of unit. Meanwhile, the values of 3, 1, 7, 4, and so on are the cost. Okay, to begin with, first step if we need to check whether the number of allocated cells equals to number of row plus number of column and minus 1. Here we can see that the number of allocated cells is 1, 2, 3, 4, 5, 6, and number of row is 3, U1, U2, U3, plus number of column 1, 2, 3, 4, 7 minus 1 is 6. So they are equal, and then we can proceed to use the MODI method. The second step is referring to the allocated cells. We now can find UI and VJ, U1, U2, U3, V1, V2, V3, and V4, where Cij, the cost is equals to Ui plus Vj. Okay, I take the allocated cells. Okay, there are 6 cells. The Ui we always set equals to 0, and then we can find V1. Okay, 0 plus V1 equals to 3, meaning that V1 is 3. Again, U1 is 0 plus V2 equals to 1. So you can find here V2 equals to 1. We now can move to the second row, U2. Okay, U2 plus 1 equals to 6. So U2 is 5. 5 plus 1 is 6. Now we can find V3. 5 U2 5 plus V3 0 equals to 5 here. Now we move to the third row, U3 plus V3 equals to 3. This cell should be 3. 3 plus 0 equals to 3. Then we can find V4. 3 plus negative 1 is 2. Now we can proceed with the third step, is calculate the penalties for unallocated cells, which is the formula for penalty is U plus V minus C. The unallocated cells are C13, C14, C21, C24, C31, and C32. Okay, the formula for penalties is Pij equals U plus V minus C. Okay, now C13, the penalty is 0 plus 0 minus 7. So we have negative 7. C14, 0 plus negative 1, sorry, plus negative 1 minus 4. So we have negative 5. And for C21, 5 plus 3 minus 2, we have 6. And we do the rest until the last one is C32, 3 plus 1 minus 3 equals to 1. Okay, then we can determine whether our solution is optimal or not. Okay, the optimality is reached if all the penalties are 0 or negative values. If we look at here, this cell is non-negative values, meaning that it is not optimal. Okay, now the cell 2-1 is a new basis form. This is the cell 2-1. Then we can draw a movement, a loop. We move to the right and we go up, move to the left, and in going down. Okay, be reminded that the loop must pass through the allocated cells only. You cannot go the other way. And now, in cells with negative sign, we choose the smaller value. Negative sign is 1 and this another one cell. Okay, there are two cells with negative sign. We choose another smaller value is 200. So we will develop a new table which is 200 plus 50 will be 250. 200 minus 250 will be 50. 200 plus 0 here will be 200. And 200 minus 200 will be 0. Okay. The first step, this is our new developed table. The first step is we need to determine whether the number of allocated cells equals to number of row plus number of column minus 1. Allocated cells we have 1, 2, 3, 4, 5, 6. Number of row 3 plus number of column 4 minus 1 is 6. If the values are equal, then we can proceed with the MODI method. And for the MODI method, we need to find UI and VJ. Now we refer to the allocated cells only. I repeat, allocated cells only, which is, okay, we start with U1. U1 is always start with 0. Then we can find the first allocated cell is this cell. 0 plus what value equals to 1? The answer is 1. 0 plus 1 is 1. Then we can find V1. Sorry, we can find U2. What value plus 1 is 6? The answer is 5. 5 plus 1 is 6. Okay, now we can find V1. 5 plus what value equals to 2? The answer is negative 3. 5 plus negative 3 is 2. Okay, then we can find V3. 5 plus 0 is 5. Okay, and now we can try to find U3. Okay, what value here plus 0 is 3? The answer is 3. And the last one, we can find V4. 3 plus what value equals to 2? The answer is 3 plus negative 1 is 2. Okay, for U and V, U, I and Vj, I refer to the allocated cells. But to find the third step is calculate the penalty. For penalty, we refer to the unallocated cells, which is C11 here, C13, C14, C24, and C31 and C32. Okay. Penalty is calculated by referring to the unallocated cells. Okay, C11, the penalty is 0 plus negative 3 minus 3 equals to 6. Okay, for C13, 0 plus 0 minus 7 is negative 7. Okay, and C14, 0 plus negative 1 minus 4. I have negative 5. And if I do until the last one, C32, the penalty is 3 plus 1 minus 3 is 1. Okay. The next step is the optimality is reached. Okay. Now we have positive here, meaning that our solution is not optimal. Yeah. And then we need to determine which is the maximum penalty. Of course, C32 is our maximum penalty. Yeah, 1 at cell 32. Then we draw a loop here. Okay, we draw a loop. We refer to the C32 column, cell row 3, column 2. We draw a loop here. Okay. For this cell, we put plus here. The next cell minus, plus, minus. Okay, the movement, as I told you, must pass through the allocated cells only. Okay, meaning that from cell 32, I move to the right, then I move upward, I move to the left and going down. Okay. Okay. Now In cells with negative sign, choose the smaller value. Negative sign 1 and 2. The smaller is 50. And we use this 50 to add and minus the closed cells. And 50 plus 100, so we should have 150 at this cell, and 50 minus 250, we should have 200 at this cell, and 50 plus 0 here, we should have 50, and the 50 minus 50, we must have 0 here. Then we will have another new developed table. Okay, this is a new one table. Hopefully this is the final table. So as usual, we need to check whether the number of allocated cells equals to the row plus column minus 1. And of course they are equal. And we determine the value of u and v. I already determined for you. And then the third step is we calculate the penalties for unallocated cells. Okay, already calculated. And the fourth step is the optimality is reached. Yes, the optimality is reached because all penalties are negative values. We can check here. All the penalties here are negative. There is no positive and no zero. So our solution is optimal. Now we can calculate the total cost, which is 250 times 1, refer to this table, 200 times 2, 150 times 5, 50 times 3, 200 times 3, and 150 times 2. Thus, the total cost is 2,450. Okay, until we meet again.